Okay, here I have a TRIAC. This was part of a phase angle controller that I've built. And what you see, this hole here, it's a burn. I actually had the wrong varistor soldered onto the across the terminals of the TRIAC A1 and A2, and I had a 200 volt by mistake fitted, and it actually burnt out, and I had it running for a while and I didn't realize. I was controlling a motor, but the TRIAC's still okay, so that was only the varistor where it burnt. So I'm gonna just use the TRIAC while it's soldered there. So I'm just gonna solder one wire there. Okay, and we'll solder it to the this section here, which is the A1. Okay, so here I'm connecting the wire to the resistor, to the gate, and I've already connected it here, sorry, onto the switch. So I just connected the resistor from there to the switch, this wire here. So now I'll have to make the snubber up here, 0.047, 47 nanofarad by 56 ohms, something like that. 1 watt, that would be. Okay, I couldn't find a 56 ohm resistor 1 watt, but I have a 47, so that's what we're going to get for now. Let's see how we go with that. So I want that across the TRIAC. And I also want to connect a varistor there. See what we've got here. I cannot see. As finished. Okay, I have to use this even with this. I'm struggling. So to undo all the solders, I'm going to have to go at different points like that. Okay. Okay, so I gotta do this wire from the switch, the other side of the switch, to this point here, which is between to that resistor there. That's in the wire. So I've got to go to here. And that will be the gate driver of there to the switch. And the switch plate is here. Okay, so I think that's all the wire. Let me just double check it. Gate, resistor, 270, one side of the switch. Yep, the other side of the switch goes to there. Okay, I think that should be it. We'll see what happens. So we'll have to put that way. Clean up a little bit. Right. Nothing is happening. Alright, let me check. Okay, so it didn't work before, but I have found the problem. And the problem was my fault. What I had is, I had the feed to get the power for the gate. Instead of it was hooked up to the A2 section, I had it hooked up to the A1. Okay, so that was on the off position there. There was no power because the SCR hasn't fired yet. So I wasn't getting any signal. Okay, so A1 and A2 were inverted, corresponding with the 56, or I put actually 47 ohm resistor. So instead of that point was, basically what I had wrong is I had the capacitor there and I had the resistor here. So in fact, this resistor was getting off A1 instead of A2. So the SCR wouldn't fire. So that was the issue. So here it is. So everything's wired up. I took off the circuit board there that I had. So I've got the SCR, just the SCR and the varistor and the capacitor and the snubber circuit. Okay. And I still have a little bit of a miss at low speed. But if I zoom in or come a bit closer to the contacts, okay, you see that obviously there cannot be any there cannot be any sparks because the switch now is only, the points are only acting to fire the gate on the SCR. So that's on low speed. You can hear it a little miss. That's because the contacts, sometimes they don't make good contact. Low speed, it's off. Okay. There's the SCR here. Sorry, not the SCR, I was saying SCR. The TRIAC. Okay. And two controls. So with this circuit, there's no spark on the points because they're only running milliamps now. So instead of the point switching, it's the TRIAC that is switching here. And of this resistor here is not needed, so that's not connected now, because in the off position, it's actually off. Doesn't run when the TRIAC is off. So the 450 ohm resistor. Okay, let me switch this off. So the 450 ohm resistor, you see it's across the switch. When the switch is in the off position, the current goes through the resistor to the motor, right? If they didn't put that resistor, you will get, as soon as you switch it on and it's running, as soon as that contact breaks, it's going to get a massive arc because you cut the full current of the motor, which in this case with the resistor, some of the current is still going through the resistor, so the motor is still running, and therefore the contacts have a reduced arcing in there. Without that resistor, even with the snubber circuit here, so the snubber circuit would have been tuned for that high spike that we're getting, but without this resistor, this will probably like arc and weld the contacts. They won't last long at all. So with this circuit though, on low speed, being that resistor is more on than off, it will get hot, and therefore that's why on here there's the fan and the resistor's right at the edge to cool the resistor down. But now that I put the TRIAC circuit, that resistor is not needed, because when the TRIAC switch is off, there's no arcing, and switch it on, there's no arcing across the TRIAC, being a silicon junction. So what do I have to do now is I have to see how I am going to put off. Obviously we don't need this big heatsink. In actual fact, the TRIAC doesn't even get hot. This is a 40 amp TRIAC, and the motor only draws 1.8, 1.6 amps. You might get a bit of a high current at startup, but this is sort of an overkill. But we still need to put a heatsink just to make sure. So I'll have to make something up. I think I would leave this resistor where it is, you know, for the originally part of it. And obviously as well, which I haven't forgot to mention, this snubber circuit for the points, which they had a 50 ohm in series with this 0.1 microfarad capacitor, which is the big capacitor, is this big one here. That's also not in the circuit now, so we don't actually need that. Okay, but I will try to leave it in there, because if this circuit for some reason it will fail, and either me or someone else wants to put it back to original, they can. I mean, if I didn't have them in there, I'll have more room to put the heatsink and the TRIAC, but I might still be able to do that, so I'll have to see how I go. I'll have to work out a bit of a design first to see how I'm going to do it. All right, a bit of a change of plan. I originally said I wasn't going to remove the capacitor and the resistor, but after having a look how everything is, this being backlight, okay, I've decided that at least I'm going to have to take the resistor off. So if I soldered one side, the other one was already unsoldered when I was doing the testing, and I pushed out these clips here that holds it in there. So you can see it's in the way of where the fan is blowing the air, so to cool down, because that resistor, I'm not sure how many watts it is, but it looks like a 50 watt to me or something. Maybe not 50 watts, but let's see. I say easily 30 watts. Okay, resistor. It's still okay. It's a ceramic. It's probably a wire wound one, from what I can imagine. The writing on it seems to has gone, unless because of my eyes I cannot see. Let's see. No, it's too hard to see anything on it. Yeah, it is a wire wound, and you can see here it's got a crack in it. Focus. No, it's switching cameras. Samsung, mate. It's not in focus, I know. How can I zoom? How can I get this? It's switching cameras over when I okay, that's better. You can see the wire wound inside, and the ceramic have started to crack. This thing is about 60 years old, but it's not open circuit, it's still running. So you can see it did get hot along the ears, and yeah. So my plan is this. I've got a heatsink here. Okay. This heatsink, if I remember right, came from a LG plasma TV. One of the boards that ran the screen circuit for the plasma was siliconed onto the ICs. So my plan is to measure up. I'll straighten this up, and I'll measure up the length of this bracket that held the resistor. Okay, let's see what we got. We got about, let's measure from the middle, 51 mil. Okay, so if I cut this 51 mil, okay, I will, it's got already holes here on each side. Okay, let me, and I will screw it onto here with self tappers, and that will fit that way. And the TRIAC, let's see, show you the TRIAC. I cannot install it that way because it's wider, but I'll install it that way, horizontal along here. So I'll install the TRIAC horizontally that way. That's my plan. Whether I have it facing the inside or the outside, I haven't decided yet whether it goes like that or like that. But first I'll cut this to length. Alright, do that. So I've cut this. Now either it fits vertical, along the vertical that way, and this will fit like that. Okay. Or I could fit it up like that and have it that way, which I suppose is not that bad either, because we're cooling the heatsink from underneath. This way, if that was that way, I suppose maybe the air might cool on the outside too, but I think for convenience, for wiring, it's probably better that way. And I'll put some insulation under here, not to isolate anything here when I solder the wires, but I could solder direct onto it, or I could put a little circuit board. I'll see what I can find. Okay, so that's the aluminium that I've cut. That's going to fit in there. Okay. And this hole was slightly small, so I had to go with the next size up drill, so I'll be able to fit the screw here. Okay, so that will screw in there. So let's see. If I can put that in and work out, probably there. See if I can make this fit. As a self tapper. Okay, that worked. So I've done it in 2 seconds without the camera in the way. So unfortunately, this is the reason why I don't sometimes film things. I don't know how people do it, but I cannot. So now that goes there. Okay. So I will be marking where I'm going to drill the hole, and we'll be there. Okay, so now it's a matter of taking this off, drill this and make a thread. First thing, we need to put a punch hole, a mark with the punch. That's good enough. Alright, so I'm going to be tapping a 3mm tap for 3mm thread screw. here I have a 2.2 millimeter drill bit. I'll see how I go with this. It's coming on an angle. Not concentrating that much. Normally I can put that tap in the chuck and just turn the drill slowly. You get better alignment. But anyway. Okay, so I fitted back the heatsink and I just screwed a screw into the thread that I just did. And I fitted the MOSFET, TRIAC. I don't keep mixing. SCR, MOSFET, it's a TRIAC. And what I think I'll be doing is, instead of having a circuit board here, which a bit of board, it's going to make it more complicated. There's no point. I'm going to have to unsolder the terminals at the capacitor that's not used. Okay. So, where's my screwdriver? So, for example, that terminal there and that terminal there. Okay. So I can use them as junctions to be able to route the wires to the TRIAC. So I'll undo those, unsolder them, do that. Alright, here I have some, actually this is transformer insulation paper, it's a rice paper from AliExpress. Not to advertise them, but I just cut out a small piece and I'm going to fit that there. There's some insulation. And just to always do the right thing, we'll put some alcohol and we'll wipe the aluminium section to get a good adhesive. So this is a double-sided tape. I remove the screw here as well, just to lower that a little bit. So there you go. So now I removed this resistor and I put the TRIAC instead. And I moved this resistor that was there before. And they will be the main terminals for the that point there and that point there. So just in between the input and output of the TRIAC, A1 and A2. I also removed, there was a choke here that was in my way and was actually soldered to the points. So when we look at the old circuit, that was that one there, the choke there to the points. So I cannot leave that in place either, I had to remove it. So these wires were routed from the top before, and after looking at this, there's going to be a change of plan. They're going to be routed underneath this capacitor. So this one is going to have to go from under here. Okay, and that will join to there, and this one will also have to go underneath, and will join to that point there. Let's see if I'm going to be happy with that. Maybe not. I'm going to rather have it just underneath the neutral there. It's not working out. One more try. Make sure it's not getting caught on anything. I think I'm going to remove this because it's in my way as well. Okay. This is going to be going up and down. Sorry for the confuffle here. And that's going to be maybe rubbing on the wire now. I don't actually like that. Not sure if I can remove this without breaking the back a lot. And I can. It's spring loaded. Well, just might as well then. I got more room definitely now. That wasn't going to be used anyway because you see that was a 0.1, and that was okay to snub as a snubber on the contacts. But it's a bit too large for the TRIAC. So this wire here can join right there. Let's apply some flux onto that. So that's that there. Okay, soldered onto the terminal there. And then we'll do the same here. So there are terminals. This going up and down. Should be okay that way. Okay. So now I need to have this capacitor here, 47 nanofarad. And I need to be in series with the resistor. So I'm going to twist this together. Okay. And we'll solder this. And cut that off. And that's going to be the tap for the pickup with the resistor to the gate. So now that goes there, but I might put the varistor first across this. Yeah. So let's see if I can bend this. Just looking through the camera like this. Let's see if they line up along that side. If I put that in like that and like that, yeah. Okay. So let's see if I can apply some thinning here. These terminals are a bit tarnished. Let's see See if I can apply a bit of flux. Doesn't like to take to it. Let's see if I scratch him up a little bit. Apply a bit of alcohol here. Clean it up, the flux, and try again. Okay, that's better. Now it took. Clean up the old flux. So let's see if I can have that in that way. Let's see if I can adjust the camera a bit better. Okay, hang on a minute. Okay. Take a seat. Shit. Just kicked off the stand of the camera. Okay. Because I still need to run wires actually from there to the TRIAC. All right. One wire here. So that part is going to be A2. So we'll have to come to this point here. like that. And I'm going to twist this around the TRIAC terminals, which I bent up. Okay. Reflux. Now, I'll change the color to the other one. Get that out of the way for now. And that will become A1. So that's the switching part. So now all that's left is the resistor maybe we should be moving a bit that way, and the capacitor across here. Let me fix this wire here. Not sure if this is soldered properly onto the wires. Okay. Maybe there's too many things here, you know. Maybe I should go at the back where the wires are. I suppose I can run the resistor wire here and leave the motor wires separate. I probably can do that. Okay. That one is like that, and let's see what I'm doing. So the capacitor that I've put, it's the 630 volt one, polyester. Okay. It's taking a focus. So that's what we got. At this point here will be the feed, the resistor, and hopefully that's correct what I did. We'll soon know, because if it's not correct, it will not work. And so here I've got a 47 ohm, not a 56, and here I'm going to have 270 ohms resistor, which is this one. And obviously I still got to run a wire. Run this wire. This is the base. The gate, sorry, not the base. Okay, so that's soldered, and I think I'll have the resistor. Solder on here. And this will join to the resistor there. So this was made up as I went along a little bit. Come on. Maybe I'll do a loop this way. Okay. Like that. So hopefully that's the whole circuit now. So here we have the motor wires, goes to the terminal at the back. The terminal's double here. This is the snubber circuit in series with the capacitor, which is all across the SCR anyway. And in between, this resistor picked up the feed for the gate. Oh, what have I done? This is wrong what I did. Okay. I forgot the switch. The switch. You see? You think you know what you're doing? Okay. But the switch all I have to do then is desolder the wire from here and go to the switch. Okay. And then to the gate. So I can have it that way. Yeah. So we'll cut this off here. And strip the wire. Send it a little bit. And we'll go to this side of the switch. It's good enough for me. which you can't see. So what it is, that's one side of the switch, and we're going to solder there. Alright. Now I'll have to again, because of the camera, so that's soldered there. Okay, and now I've got to go from the switch to the gate. So before I went straight to the gate, of course that wasn't going to work. That means that was going to be on all the time. And now I will run another wire to this point. And now we'll go run it that way away from the adjustment. The camera a little bit up. And we'll go to the gate of hell. Okay. Technically this I didn't really have to twist them, but together I don't have to really twist it around the terminal. This is like warranty. Okay. So that should be done now. Okay. All that's left is to try it. So let me set that up now. Just got to put a bit of compound. What do you call it? Heat sink compound. Because I didn't put that. Not that it really needs it for this, because as I said, this TRIAC I'm pretty sure will run cold. I put a spring washer underneath the screw to make sure it doesn't come off with vibrations or anything like that along the ears. Anyway, this is more of a hobby for me. So that's done. So regarding the circuit diagram, the 56 was changed to 47 ohm in my case, and the 220 was a 270 ohms, and I also added a varistor, okay, onto the TRIAC, whatever how they draw it. So varistor, and that was a 430 volt. So that's what I did, and I left that capacitor the same, 0.047 microfarad. Yeah, so I thought I'll put that in as well. I hooked up the power onto the terminals there, the mains, and I actually hooked up the oscilloscope across the points, which is the input to the gate of the TRIAC. So let's see. That's some low speed. It's still got a little miss every now and again. They're completely off. And interestingly there, it's reading 182, 187, 190 volts. Volts. Anyway, that was that test. If you recall, in the episode 1 of my videos, I had a big gap here when this was locked. Okay, I have fixed that problem, and that problem had to do with the latch. So let me pause it and go on to the where the latch is. So there's the latch at the top when it locks. Okay, and what it was, it had wear here, right? Or somebody have filed this. Or what it could be is the wear was from the planetary hub was not running through, which means it was not running circular because it was running on an angle. So the constant hitting, it could have been hitting the mixing bowl, and therefore that section where the latch is was moving in and out, okay, and jerking, which could have worn out that section, because I did find wear on the pin as well. So even the pin had wear. So that could have been that. So the problem was that hub running for a long time on an angle.